Okay, so on June 24th, 1948, the former Soviet Union blocked all land and water routes through East Germany to Berlin. A gigantic airlift was organized using American and British planes to bring food, clothing, and other supplies to the more than 2 million people in West Berlin. The cargo capacity was 30,000 cubic feet for an American plane and 20,000 cubic feet for a British plane. To break the Soviet blockade, the Western Allies had to maximize the cargo capacities but were subject to the following restraints. So they could only use 44 planes. The larger American planes required 16 personnel, and double that of the British, so then the British are each 8. Okay, and the total number of personnel could not exceed 512. The cost of an American flight was $9,000, and the cost of a British was $5,000. And the weekly totals could not exceed 300,000. Find the number of American and British planes that were used to maximize cargo capacity. Okay, so I wrote down this basic information. So the first thing is obviously get yourself a list of all this information so you can write your equations. And I'm going to start by writing the objective function. So we want to maximize cargo capacity because we want to maximize as much food and other supplies as we can get in. So our objective is going to be 30,000 for an American plus 20,000 for a British plane. X is American and Y is British planes. Okay? And so this is our objective function. Okay, this will be the most that we can do, and obviously the more American planes the better, but they cost more and they're more personnel, so you have to equate that. So then we have here, what are our constraints? Well, obviously we have to be positive. We're not going to send negative planes flying. Okay, so we're only in the first quadrant. So when we draw our graph, we want to, this just tells us first quadrant. Pretty much you probably realized all these are first quadrant. Okay. Then, not more than 44 planes. So, our first one is that x plus y has to be less than 44. Okay, then we have personnel. So, each American is 16. So, 16 per, per American plus 8 per British. And this has to be less than 512. Then we have cost. It's 9,000 per US and 5,000 per British, and this has to be less than 300,000. So these are our 5 constraints. So I'm going to come over here and I'm going to now switch to Desmos and I'm going to graph these. And this is one where I would totally not try to hand graph it. Let's see here. Desmos, there we go. Okay, so I have x plus y, not u. It doesn't really matter, obviously, what. Okay, has to be less than 44. Okay, and then I have 16x plus 8y has to be less than 512. And 9,000x plus 5,000y has to be less than 300,000. Okay, I'm going to change this color. Green. Okay, so let's see if we can kind of play with our things a little bit. Where are our constraints here? So let's see here. This is going to be down, down. Okay. You can't see it by playing with this on with my fingers as I'm trying to get it. Just so you remember, sometimes if this is being a pain, remember there's the little wench over here and you can manually do it as well. But these should be there, there, and there. Those should be, and then 0, 0, but obviously we're not going to send no planes. So, you can write it down if you want. So 0, 44, 20, 24, or this last one over here was 32, 0, or we could have 0, 0, but, that's pretty easy to tell that's not our maximum. So we've done all these. Okay. Now what I have to do is I have to come over here and I have to plug each one of these into my objective equation. My objective equation was this 30,000x plus 20,000 y, okay, equals z. So obviously 0, 0, and that gives you a 0. What if I just sent 44, all 44 British? So 44 times 20,000 would give me 888,000. So this is 0.44, okay? Then 2024, so that's 30,000 times 20 plus 24 times 20,000. Half of the battle is keeping the decimals. So this is 108, then 1, 2, 3, 4. So this is 1,080,000. And then the final one is if I send, what happens if I send only American planes? So then 32 times 30,000. So 32 times 30,000 gives me 96,000. This is our winner. We want to send 20 American planes and 24 British. So the solution is 20 American and 24 British to maximize the amount of supplies into Berlin. And you can see that'll give us over 1 million cubic feet of cargo space for all those supplies. So first step, write that objective equation, whatever you want to maximize or minimize. Then you are going to write your constraints and graph them. I highly recommend with these, especially start getting 3, 4, 5. That's what things like Desmos were invented for. And remember, if you don't already have it, it's a free app on your phone. But I like it on the big screen of the computer. I'm going to be honest, but that might just be me being old. But in any case, works really good. It's free, whether you use it as an app or use it on the computer. And then you need to, once they're graphed, you're going to find all those vertexes, the corners, plug each one in the objective function until you get the answer. Remember, you don't graph the objective function. You test with it.